Listen to a conversation between a student and a counselor at the University Counseling Center.
Hi, thanks for seeing me on such short notice.
No problem. How can I help?
Well, I think I might have made a mistake coming to this school.
What makes you say that?
I'm a little overwhelmed by the size of this place. I come from a small town. There were only 75 of us in my high school graduating class. Everyone knew everyone. We all grew up together.
So it's a bit of a culture shock for you, being one of 15,000 students on a big campus in an unfamiliar city?
That's an understatement. I just can't get comfortable in class or in the dorms, socially.
Well, let's start with your academics. Tell me about your classes.
I'm taking mostly introductory courses, and some are taught in these huge lecture halls.
And you're having trouble keeping pace with the material?
No. In fact, I got an A on my first economics paper. It's just that it's so impersonal. I'm not used to it.
Are all your classes impersonal?
No, it's just that, for example, in sociology yesterday, the professor asked a question, so I raised my hand. Several of us raised our hands, and I kept my hand up because I did the reading and knew the answer. But the professor just answered his own question and continued with the lecture.
Well, in a big room, it's possible he didn't notice you. Maybe he was trying to save time. In either case, I wouldn't take it personally.
I suppose. But I just don't know how to, distinguish myself.
Why not stop by his office during office hours?
Well, that wouldn't seem right. Taking time from other students who need help.
Don't say that. That's what office hours are for. There's no reason you couldn't pop in to say hi, to make yourself known. If you're learning a lot in class, let the professor know. Wouldn't you appreciate positive feedback if you were a professor?
You're right. That's a good idea.
Okay, let's turn to your social life. How's it going in the dorms?
I don't have much in common with my roommate or anyone else I've met so far. Everyone's into sports, and I'm more artsy, into music. I play the cello.
Have you been playing long?
Since age 10. It's a big part of my life. At home, I was the youngest member of our community orchestra.
You're not going to believe this. There's a string quartet on campus, all students. And it so happens the cellist graduated last year. They've been searching high and low for a replacement, someone with experience. Would you be interested in auditioning?
Absolutely. I wanted to get my academic work settled before pursuing my music here, but I think this would be a good thing for me. I guess if I really want to fit in here, I should find people who love music as much as I do. Thank you.
My pleasure.
What do the speakers mainly discuss? Why does the woman mention her hometown? What does the woman imply about the incident that occurred in her sociology class? According to the counselor, why should the woman visit her professor's office? What does the woman imply about joining the string quartet? Listen to part of a lecture in a sociology class.
Have you ever heard the one about alligators living in New York sewers? The story goes like this. A family went on vacation in Florida and bought a couple of baby alligators as presents for their children, then returned from vacation to New York, bringing the alligators home with them as pets. But the alligators would escape and find their way into the New York sewer system, where they started reproducing, grew to huge sizes, and now strike fear into sewer workers. Have you heard this story? Well, it isn't true, and it never happened. But despite that, the story's been around since the 1930s. Or how about the song Twinkle, Twinkle, Little Star? You know, twinkle, twinkle, little star, how I wonder what you are. Well, we've all heard this song. Where am I going with this? Well, both the song and the story are examples of memes, and that's what we'll talk about, the theory of memes. A meme is defined as a piece of information copied from person to person. By this definition, most of what you know, ideas, skills, stories, songs, are memes. All the words you know, all the scientific theories you've learned, the rules your parents taught you to observe, all are memes that have been passed on from person to person. So what, you may say? Passing on ideas from one person to another is nothing new. Well, the whole point of defining this familiar process as transmission of memes is so that we can explore its analogy with the transmission of genes. As you know, all living organisms pass on biological information through the genes. What's a gene? A gene is a piece of biological information that gets copied or replicated, and the copy or replica is passed on to the new generation. So, genes are defined as replicators. Genes are replicators that pass on information about properties and characteristics of organisms. By analogy, memes also get replicated and, in the process, pass on cultural information from person to person, generation to generation. So memes are also replicators. To be a successful replicator, there are 3 key characteristics: longevity, fecundity, and fidelity. Let's take a closer look. First, longevity. A replicator must exist long enough to be able to get copied and transfer its information. Clearly, the longer a replicator survives, the better its chances of getting its message copied and passed on. So longevity is a key characteristic of a replicator. If you take the alligator story, it can exist for a long time in individual memory, let's say my memory. I can tell you the story now or 10 years from now. The same with the Twinkle Twinkle song. So these memes have longevity because they're memorable for one reason or another. Next, fecundity. Fecundity is the ability to reproduce in large numbers. For example, the common housefly reproduces by laying several thousand eggs. So each fly gene gets copied thousands of times. Memes, well, they can be reproduced in large numbers as well. How many times have you sung the Twinkle Twinkle song to someone? Each time you replicated the song and maybe passed it along to someone who didn't know it yet, a small child maybe. And finally, fidelity. Fidelity means accuracy of the copying process. We know fidelity is an essential principle of genetic transmission. If a copy of a gene is a bit different from the original, that's called a genetic mutation. and mutations are usually bad news. An organism often cannot survive with a mutated gene, and so a gene usually cannot be passed on unless it's an exact copy. For memes, however, fidelity is not always so important. For example, if you tell someone the alligator story I told you today, it probably won't be word for word exactly as I said it. Still, it will be basically the same story, and the person who hears the story will be able to pass it along. Other memes are replicated with higher fidelity, though, like the Twinkle Twinkle song. It had the exact same words 20 years ago as it does now. Well, that's because we see songs as something that has to be performed accurately each time. If you change a word, the others will usually bring you in line. They'll say, "That's not how you sing it," right? So, you can see how looking at pieces of cultural information as replicators, as memes, and analyzing them in terms of longevity, fecundity, and fidelity, we can gain some insight about how they spread, persist, or change.
What is the main purpose of the lecture? Why does the professor tell the story about alligators? According to the professor, which of the following are examples of meme transfer? What example does the professor give of a meme's longevity? What does the professor compare to a housefly laying many eggs? Why does the professor say this?
If you change a word, the others will usually bring you in line. They'll say, "That's not how you sing it," right?
Listen to part of a lecture in an astronomy class.
Last week, we covered some arguments against going back to the moon. But there are compelling reasons in favor of another moon landing, too, not the least of which is trying to pinpoint the moon's age. We could do this, in theory, by studying an enormous impact crater known as the South Pole Aitken Basin. It's located in the moon's south polar region, but since it's on the far side of the moon, it can only be seen from space. Here's an image of, we'll call it the SPA basin. This color-coded image of the SPA basin, those aren't its actual colors, obviously. This image is from the mid-90s, from an American spacecraft called Clementine. Unlike earlier lunar missions, Clementine didn't orbit only around the moon's equator. Its orbits enabled it to send back data to create this topographical map of, the gray and white area towards the bottom is the South Pole. The purples and blues in the middle correspond to low elevations, the SPA basin itself. The oranges and reds around it are higher elevations. The basin measures an amazing 2,500 kilometers in diameter, and its average depth is 12 kilometers. That makes it the biggest known crater in our solar system, and it may well be the oldest. You know, planetary researchers love studying deep craters to learn about the impacts that created them, how they redistributed pieces of the planet's crust. And in this case, we especially want to know if any of the mantle, the layer beneath the crust, was exposed by the impact. Not everyone agrees, but some experts are convinced that whatever created the SPA basin did penetrate the moon's mantle. And we need to find out, because much more than the crust, the mantle contains information about a planet's or moon's total composition. And that's key to understanding planet formation. Diane?
So the only way to know the basin's age is to study its rocks directly?
Well, from radio survey data, we know that the basin contains lots of smaller craters. So it must be really old, about 4 billion years, give or take a few 100 million years. But that's not very precise. If we had rock samples to study, we'd know whether these small craters were formed by impacts during the final stages of planetary formation, or if they resulted from later meteor showers.
But if we know around how old the basin is, I'm not sure that's reason enough to go to the moon again.
No, but such crude estimates, we can do better than that. Besides, there's other things worth investigating, like, is there water ice on the moon? Clementine's data indicated that the wall of a south polar crater was more reflective than expected, so some experts think there's probably ice there. Also, data from a later mission indicates significant concentrations of hydrogen and, by inference, water less than a meter underground at both poles.
Well, if there's water, how'd it get there? Underground rivers?
We think meteors that crashed into the moon, or tails of passing comets, may have introduced water molecules. Any water molecules that found their way to the floors of craters near the moon's poles, that water would be perpetually frozen because the floors of those craters are always in shadow. Furthermore, if the water ice was mixed in with rock and dust, it would be protected from evaporation.
So are you saying there might be primitive life on the moon?
That's not my point at all. Okay, say there is water ice on the moon. That would be a very practical value for a future moon base for astronauts. Water ice could be melted and purified for drinking. It could also be broken down into its component parts, oxygen and hydrogen. Oxygen could be used to breathe, and hydrogen could be turned into fuel, rocket fuel. So water ice could enable the creation of a self-sustaining moon base someday. A mining camp, perhaps, or a departure point for further space exploration.
But hauling tons of equipment to the moon to make fuel and build a life support system for a moon base, wouldn't that be too expensive?
A permanent base may be a ways off, but we shouldn't have to wait for that. The dust at the bottom of the SPA basin really does have a fascinating story to tell. What I wouldn't give for a few samples of it.
The main purpose of the lecture. What does the professor imply about the spacecraft Clementine? Why does the professor mention the moon's mantle? Why is the South Pole Aitken Basin thought to be exceptionally old? Why does the professor consider it important to find out if water ice exists on the moon? Listen again to part of the lecture, then answer the question.
But if we know around how old the basin is, I'm not sure that's reason enough to go to the moon again.
No, but such crude estimates.
What does the professor imply when he says this?
No, but such crude estimates